Hey guys, I'm Pat Kelly. Okay, in this problem, we're going to find a probability. The experiment is that a coin is tossed 3 times. Specifically, what we're going to find is the probability of getting exactly one tail in that experiment. Okay? Now, the best way to start when you're thinking of how to set up a probability problem is think of finding that probability as a fraction. So my probability of any event is a fraction, where the numerator of the fraction is the number of ways that that desired outcome, that event, can occur. So that notation is the number of ways we can get what we want, exactly one tail in this case. The denominator of your fraction is the total number of ways that that experiment could play itself out. And I'm talking as I'm writing, and as you're hopefully seeing what I'm writing, is this notation. That capital S should look familiar. That's your sample set, your sample space. And the N is just the size of your sample space, the number of elements in the sample space. So you find each of those 2 pieces of the puzzle, put them together as a fraction, you got your answer. So let's do that in this problem. Slide over here. And you want to get a handle on what your E is going to look like, what it might look like. Our E, our event, is getting exactly one tail. So that could happen if the first toss of the coin is a tail, but then the second toss is a head and the third toss is a head. Okay? That's one way we could win. Another way we could win is heads, tails, heads. And the third way we could win, which is the only other way in this game, heads, heads, tails. Any other possible result of tossing that coin 3 times is going to have more than one tail or no tails. This is the only way to get exactly one tail. And this is actually a set, but what's really of interest to me in this problem is the size of that set. So my N of E here is just the number of guys that you just listed. 1, 2, 3. So 3. Okay? Now I also need this N of S, the size of your sample space. And the size of your sample space in this case, I'm going to resort to that fundamental counting principle, where if we're tossing the coin 3 times, you have 3 different situations that you can account for. The first situation is just tossing that coin the first time, and you could get one of 2 possibilities, heads or tails. Second toss of the coin, one of 2 possibilities. Third toss, also 2 possibilities. And that fundamental counting principle just says to multiply those. So 2 times 2 times 2 is 8. Okay? So back to our actual answer here. The probability in this problem is the numerator of 3 and the denominator of 8. Final answer of 3/8. If I could reduce the fraction, I would, but I can't, so I'm done. Okay? Practice some more on your own.